Alright, so come back with another one-on-one lesson in math, and I have this student here, it's Anne, and he's working on a topic examining lines of best fit in a graph. So basically, graphing. Alright, and please continue.
As the distance from the net increase, the number of baskets may increase. This is false because
It's like
it's falling down when the basket are going to the
so
right.
it's like if the distance from the net increases, it just the number of baskets just decreases, right?
Yeah.
So disagree.
Search correct. The graph can be used to determine the number of basket you would take if you know the distance from the basket. I believe this is. I think I.
Yes, what do you think?
So I agree with this because
Because
wait, sorry.
hello? Yes.
Yeah, I forgot what to say. Sorry.
Okay, so what's your answer for this? Since I follow like a line, right? Of best fit. You can use that line to determine like number of basket. If you know the distance from the basket, right?
Oh, sorry. I was
So
sorry.
what do you think about this question?
The graph can be used to determine the number of basket you will make if you know the distance from the basket. So yeah, I agree with this because since
Sure.
you are far away, it's hard to make the shot from the basket. But if you are like close enough, you can actually make a shot. So that's why there are like more number of basket like going into like the ball going into the basket. But when you are stepping further away, it's like much harder to make a
To hit it,
shot from
yeah, much
it.
harder to hit it. And it follows a
So
relationship, so of course you can determine, right?
yeah, I agree.
So it follows a relationship, you can say that. So okay, house price, age of house. Of course, it's weird, you know. Okay, so what can you see here?
It's like all scattered
It's
everywhere. So
all over the place. So it means it doesn't follow any kind of pattern, isn't it?
yeah,
You might think that basically if the house is older, the price should be lower, right? No, but it doesn't
yeah,
work that way because it depends on other factors. Like for example, the location of the house. Uh, it also depends on like, do people want to buy from that place or not? If the more people want to buy, of course, the more the price will go up. But it doesn't really depend on only one factor, like the age of the house. So that's why you see it's everywhere like this.
so that's why it's so scattered everywhere because
Yeah, so
it's
agree.
so random. More expensive. Yeah, so it's like both way because there isn't really much you can tell because it's like totally random. So
Hmm.
you don't know if
It's totally random. You cannot even tell any kind of relationship or any kind of what's it called, equation that you can get from here.
yeah. Question 3 out of 3. The graph can be used to determine the price of the house
If you know how old it
if you
is.
know how old it is. I disagree with this because the uh, in this graph it show that the age of a house when it increased, the price would become cheaper or
It is random, so
higher
you
it
cannot
is.
know exactly. You cannot determine, right?
Yeah,
It's
you
just
can.
random everywhere, so you cannot just determine by looking at the graph because they don't follow any kind of relationship or any kind of how can I say pattern.
Yes, so this one is disagree.
Okay.
Understanding linear relationship. For each of the following, determine if the graph show a linear relationship. How does one variable relate to another variable? Number of caught versus number of people fishing. Number of caught, number of people fishing.
It's weird.
So
So it's like at first it seems like from 0 to 130 people fishing. It follows a kind of relationship, right? It's going
yeah,
up. It's going up. But then from like 140 to say 180 people's fishing, it's just going down. It's the opposite.
yeah. So
I mean, it's like there are two different relationship you can see here, depending on like how many people are fishing, like the range, different range. They show different relationship. That happens. Yes, that happens.
yeah, so uh,
Yeah, you lost the share screen again. Okay, you lost the share screen again.
all right. Let me get it again. Oof. Where I'm sharing it now.
Please share again.
Yeah.
Okay, you're starting sharing. Okay, got it.
can't hear me. Can you hear
Sure,
me now?
I do.
So it say that the more caught are like caught by the people, like soon it will become less to caught because since so many
It's like you have to
cop
see
are
like the range. It's like there are two different there are two different areas now. In the first area, it's like from 0 to 130. The
yeah
more people fishing, the more carp will be caught. But then from the second area, from 140 to say 100,
yeah
it's the opposite. It's the other way around. So it's like you have to divide into two areas, I think.
yeah. So it's like when people are like a lot of people are like caught a lot of carp. So when people are like fishing, like people like there's like the number of top right here, so it will be like less for the people other people to go fishing. So less cop are like being caught.
It's like it's saturated, when there are too many people carp fishing, they will start to compete with each other.
Yeah.
And
So
so less and less will be caught. I mean, less and less carp will be caught.
yeah.
I'm on wood with Stevie.
So the relation is fairly linear. As the number of people fishing increase, the number of part caught increase.
Yeah, because you see, most of the points on this graph are like going up. Only the three last points are like going down, isn't it?
Yeah.
So that's why they say the relation is very linear. It's like you have to see the whole picture first. Like most of the points are just going up like that, but only 3 points going down. So we can ignore them, kind of. Okay.
Okay.
Okay. Homework
Homework
versus
versus
TV.
TV.
Hmm.
So
Most of the time,
in
we
this,
cover.
there will be like homework versus TV. Number of hours spent doing
Homework.
homework. Number of hours spent
Spend watching
watching
TV.
TV.
Despite some weird out of the pattern points, most of them just going down, isn't it?
Yeah. So so the person is like watching more TV than doing their homework. So until it goes down, like so they would completely forget about their homework and still watching TV for
Mm-hmm.
like hours. Like so. This is called a weak linear
Linear
relation
relation.
because the points are scattered and many would be quite far away from the line to best fit. As the number of hours watching TV increase, the number of hours spent doing homework
Decreases.
decreases. Yeah,
Mm-hmm.
sorry. So it's like the person's watching more TV than doing their homework. So the homework start like going down and down, and TV's
Okay, if
like
you
at the
say
bottom.
so.
So
If you say so.
yeah, this is it to like to examining lines of best fit.
Oh, you lost your share screen again, and then your microphone's off again. This is a constant struggle. It's a
Oh wait, no,
constant.
no, no.
Say
Like
again?
I'm sharing it right now. It's like a new
Oh
one
no, I
because
know. It's a constant struggle. So did you check for when you will have your math exam? Did you?
oh there.
What do you mean there? Okay, I see that. But did you check when you will have your math exam?
The exam.
Yeah, should check it out.
Um, yeah, sure.
Don't forget. Oh, you haven't shared your screen now. Come on, please. Just don't touch it.
Yeah. Sorry.
I mean, just don't touch it. It's always like this. I don't know why, but it's always like that. Okay,
Yes.
so now you identify a linear relation. If you have data, and the graph of that data shows a linear trend, then you are looking at a linear relation. What? Okay. Decide whether
It's
it's
like right here.
linear or
The
non-linear. Okay, just go on and
this.
decide it.
So this is a linear relation.
Mm-hmm.
Yeah, because this is a non-linear relation because it's like all bending and scatter. So yeah, it's a non-linear relation. This one is also not a linear relation because it's all curved and doesn't really have a point. Yeah. This is also a non-linear relation. This one's a linear relation because it's like straight and there's like you can see where it's coming from and the point. Zach tracked the temperature. Graphing can take time. There were another method to identifying linearity straight from the data. That would give us an advantage. Let's take a look. another way. Zach decided to keep track of the temperature for one day. His data is in the paragraph below. Make a table of value to summarize the information. Zach decided to keep track of the temperature for a day. He has a thermometer that measures temperature in degrees Celsius.
And he start measuring when he gets up in the morning. Uh-huh.
And he start measuring when he gets up in the morning at 7 a.m. and the
The thermometer
ter-
reads 21 degrees Celsius.
after breakfast at 8 a.m. it's 23 Celsius. 2 hours later, the reading is
27.
27
And
Celsius.
now it's 29. It's getting hotter and hotter, of course.
By mid-afternoon, 2 p.m., it is 31 Celsius. By super time, 6 p.m., the temperature have dropped to 25 degree. 2 hours later, it is 22 degree. When Zach goes to bed at 10 p.m., it is 20 degree.
Okay.
To make the entry easier to read, convert all
Water
the
times
time
in the 24 hours format.
from
Uh-huh.
10 a.m. to
No, no, no. 1
12:59
a.m.
p.m.
to 12:59. Uh-huh.
7 a.m. becomes 7 from 1 p.m. to 11:59 p.m. Add 12 hour, e.g. 2 p.m. is
1400.
1400. Yeah. Once complete,
Okay,
press the
you do
show.
it. Okay. Just input into that table and then.
So so at 7 we have 21 Celsius. 8 a.m. is 22 Celsius. 10 a.m. is 27 Celsius. 12 p.m. 29. 14 is 31. 18, 25, and 21 is 22. 22 is 20. The relationship linear. Taking exact research the information in the graph and create a clear
Clear
table
and
value.
concise table of values.
Yeah. This is the table value that Zach recorded. It's not a linear relationship because you can't really tell what time is going to change because
You can
at
tell.
7's like at 21, 8 it's 23, 10 27, 12 29, and 14 31. So there's like no parent pattern in the table of value. So it's just random, like a scatter plot.
Okay.
So it's like not non-linear. Looking at the table, you can see the temperature rose and fell. It is easy to extract information from the table from a word description. You could even predict the temperature.
Was at a time when Zach didn't take a reading.
For example, you would probably be correct to say at 9 a.m. the temperature was about 25.
Uh-huh.
Can you decide whether the two variables, time and temperature, are linear related? You might remember that they are linear related if their data is like a straight line. Let's use a graphing app to create a plot from exact data and determine if the temperature and time linear related. So there's this. So it's like this. So this is like a graph. So this is not a linear relationship. It's non-linear because it's very messy on how it's very messy on the graph. So
Are
this
you
is a
sure it's messy?
non-linear.
I mean, it's linear at least from A to E. It's linear, but then
Yeah, and then from E to G is like it's falling off. So
of course it don't follow a straight line.
yeah,
But they say that because 5 and 2 point. I mean, they are quite significant to each other, so that's why they say it's non-linear. But if you say, let's say, you have 10 points, A B C D E F G H I A J K something, then you have 2 point that is out of the pattern. Then you can say it's still linear. You understand what I'm talking about?
yes, I am.
If you have a lot of points, like it follows a pattern, and then just 1 or 2 points that is out of the pattern, then you can say that the relation is actually linear. But in this case, 5 going up, 2 going down, it's quite significant to each other, so you cannot say that it's linear. Yeah.
Yeah, so this is more of a non-linear. Is there a shortcut to decide whether the relationship is linear or not? Construct a scatter plot and see of the point. Make a straight line. The only trouble with the method is that it takes too long to make a scatter plot, right?
Uh-huh.
If only there was a way to tell if a relation was linear or not just by looking at the table value. Well, there is. Let's see if you can find it. Once the relation is short of linear, you figure it out. Examine the data in the table below to determine if it's a linear relation or not. Select the Show Suggested Answer button to see the table graph. Does the data in the table A produce a linear relation or a non-linear relation? This is the non-linear relation. So it start from 0. Can I take a little break?
Sure. Let's take a break. Okay. Right. The data shows a. Okay. Okay. Practice calculating differences. Linear relation.
Let's have a look at the table below and focus the difference between the consecutive y value.
values.
You can check if you're right by clicking in the differences button under each table. Table A, 0, 28,
They
25.
ask you to focus on the difference between consecutive y value, not x.
So it's minusing 3 each time. So for table B, it's minusing 3 and 2 and then 1. And then it's like minusing 5, 13, and minus 2, so it's a non-linear relation. Table C is just adding 5 each time. Yeah. First difference. A set of data has a linear relation if the first difference of both column in its table of value are constant. First determine help to identify whether relationships are linear or nonlinear before graphing. I already watched the video, so try this question. So, is this set data linear? Practice calculating first difference and using the calculation to decide whether the relation in the table are linear or nonlinear. Answer the question for each table. Answer table E. Is it if the difference are constant, enter the value. If not, enter NA. Table F. Are the first difference constant? Is it a linear relation? Is it a linear relation? Table G. Are the first different constant? Is it a linear relation?
Someone's playing piano.
Sorry.
No, it's fine. I'm a piano player too, I know. I realize.
Volume versus temperature of a balloon. What is the connection between first difference and rate of change? Consider this example
To find out.
to find out. Use the following graph to create a table of values from the table to time change. So start from 400. The temperature is increased to 50 degrees Celsius, and then 100 is at 440, so 150 at 60.
Maybe I'm craving for milk tea now.
So the so rate calculation. Remember, a relation is linear when it can be shown to be a straight line on the graph. The volume of the air in the balloon increased by 200 millimeter as the temperature increased by 50 Celsius. Rate change in dependent variable, change in independent variable. So 20 MC rate, so 20 milliliter divided by 50 Celsius, the rate is equal to 0.4 milliliters Celsius. Calculating the first difference from graph. It is possible to calculate the first difference from the graph of a relation. You would not normally need to do so, since the main use of the first difference is to decide wherever a relation is linear. If you already have a graph of the relation, you need to check only whenever the graph is a straight line to see if it's linear. If you want to, however, you can determine the first difference from a graph. All you have to do is see how much difference there is between the value
Mhm.
of the vertical axis dependent variable at equal interval on the horizontal axis independent variable. The result
Of a linear relation.
the result of a linear relation looks like a staircase with
With
step of
steps
equal
equal
depth
with
and
depth and
height.
height.
Recall the graph of the relationship between the temperature and volume of the
Boom.
balloon.
So they just calculate the differences after each jump. After each time jump, 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 you've calculated the difference.
Yeah,
Okay.
The graph showed the first difference are the same because for every increment of 50 degrees Celsius, the volume increased by 20 milliliter. You can now see from both the graph and the first difference that this is a linear relation. First difference in rate of change. The main reason to find the first difference on a graph that you know show a linear relation is to calculate the rate of change. If you know the first difference for the graph of linear relation, you can also calculate the rate of change for that linear relation. Early in this lesson, you learn to calculate the rate of change by dividing the change in dependent variable by the change in the independent variable. The first difference of a linear relation are change in the dependent variable, and the difference between the vertical grid line on the graph are the changes in the independent variable. So, to calculate the rate of change of a linear relation from a graph, divide the first difference you calculate by the distance between the vertical grid line. This can be done using an equation that uses the same component as the equation for the rate of change that we use at the beginning of this lesson. For the graph that compares the volume and temperature of a balloon, the rate of change would be calculate the using the following. Rate change in dependent variable, change in independent variable. So it's like before.
What
Number one.
characterizes linear relation? Of course, you will see that there's gonna be like y equal to ax plus b. So what characterizes it? It's basically the a and the b in that formula, right?
Yeah.
Okay, so let's continue.
A car rental costs $100 plus $5 for each 100 kilometer driven.
Mhm.
So so this is linear.
It is. So basically, it doesn't matter how much you drive it. You just have to pay like a flat fee, like $100, right?
Yeah.
And then for every 100 kilometers driven, you have to plus $5. Um, yeah, it's a linear relation because it just go from a base and then go up by a small difference, like the same similar difference, right? Just like $100 and then going up 100.05, 110, 115, 120, 125, 130. That's right.
Yeah,
So it's a linear relation. It is.
like it's going like in a straight line. It doesn't curve or wait what? The area of a square depends on the size of its side. Hint: you can make a table value for the area of a square with side length of 1 centimeter, 2 centimeter, 3 centimeter. So so I think this. I'm not really sure about this.
Okay. Size of its sides. So of course, a square. All the sides are the same, right? So there are four.
Yeah,
There are four sides to a square, but all of them are the same. So let's say you can make a table of values for area of the square with side length of 1. So if it's like, let me say, side is 1 centimeter, it will result in the area of 1 cubic centimeter, right?
yeah.
Because you have to square it. And if side is 2, area is 4, isn't it?
Yeah.
And if side is 3, area is 9. And so on.
So it's not a linear
It's not.
relation
It's not.
because
It follows like something called exponential relationship. It's not linear. It's exponential. You will learn it later. It's called exponential, but it's not linear.
so this is a non-linear relation.
Mhm.
The area of the square does not increase at a constant rate as the side length increase. When the
Agree.
side yeah, when the side length increase from 1 centimeter to 2 centimeter to 3 centimeter, the area increased from 1 centimeter square to like 4 centimeter square to 9 centimeter square, and so forth. Temperature start at 25 degrees and drop by
2
2
degrees
degrees
Celsius each
Celsius.
hour. Mhm.
It's a linear.
Mm. Yeah, because each hour is like 2, drop 2, drop 2, drop 2, drop 2.
Yeah.
It's like that.
For the first 10 week of his diet, Fred lose 2 pounds each week. For the next 10 week, he lose only 1 pound per week. What?
So it's tough to do this, This is all. This is not something practical because people don't lose pound like this. They lose pound randomly.
It's just random.
It's just random. In practice, nobody lose pounds like this. So for the first
Well,
10 weeks of his diet, Fred loses 2 pounds each week. So first 10 week is like 2 pounds each week. So after that 10 week, he loses 20 pounds. But for the
it's not.
next 10 weeks, he loses only 1 pound each per week. Because he basically is at his body's limit.
So
Or
this
otherwise, he
is
could be extremely obese. Let's just say, like, they started with, like, say, 200 kilograms or, like, about 400 pounds. Extremely obese, then you can be that much. Then you can lose a lot. But be careful, because when your body drops that fast, you will have most likely have problem with your heart or something like that later. Because the heart had to pump enough blood to feed that much fat cells, and then when you lose it all, it's like the heart's like, okay, it's not used to the new situation when you have to feed less cells, but it's better than when you gain. It's like when you gain a lot of weight at once, it strains the heart, it makes it very stressful for the heart. Anyway, let's do this one.
so it's it's not a linear relation. Oh, this is an example of piecewise linear relation, where there are different linear segments that describe a scenario. Each segment can be treated separately and described as its own linear relation. 2. State the rate of change for the following linear relation. A pizza costs 9.99 for 3 basic topping, plus 0.50 for additional topping. So um,
Yes. Basic topping. Additional topping. The rate of change.
So this is pizza costs
Costs. Be careful with your
$9.
grammar. Be careful with your grammar. Costs with S.
Oh yeah, sorry. And plus $0.50.
So the rate of change is not $0.5 then.
Yeah, so the rate of change is $0.50. Yeah. For every 3 minutes that you use a payphone, it costs $4.50.
Who uses
Right.
payphone anyway? I mean, these days people don't use payphone anymore. It's just in America.
Rate of change is $4.50. And it's an a linear relation. Oh, so yeah. The fee schedule for shoe gym membership is shown in the graph below. Total cost. So the rate of change is $200 for every 4 months, for 4 months each. So it's $50 month.
That's the rate of change. It's like the difference in y values divided by the difference in x value, right? Isn't it?
Yeah.
So basically, we have an equation here. That's why it's the rate equal to the difference in y value divided by the difference in x value. There you go.
Okay.
So the rate, this is the rate. It also tells you something called the slope of the graph. You know how steep the graph is. Is it going down or going up? How steep it is? It's a slope. It's called the slope of the graph. It's the same
Yeah.
thing. So rate slope is also determined in the same way. Difference in y value divided by difference in x value.
Yeah, I understand. Rectangle pattern,
Pattern.
so it's just like, so this is diagram, so there's like, so it's,
You think it's linear?
yeah, it
It
is
is. So
linear.
1, 3, 5, 7. It's increased by 2 by each time it jumps.
Yeah, yeah, so 1, 3, 5, 7 is linear. So these are words that could help me with the to identify linear relation, like rate of change, first difference, linear relation, independent variable, dependent variable, table of value, and a graph. And yeah, this is it for 3.6.
Identify linear equation. That's it, right?
Yeah,
Are you
the
sure?
end.
There should be
I can't
more
scroll down.
exercise. There should be more exercise, I think.
Well, I think I think they put more in like the next like,
Then you try to go there, I think.
yeah. Hold on.
Hold on.
Yeah, I can't really go there.
You can't? Okay, and you can't really share screen either.
Yeah, sorry.
Why? What's the problem? Why couldn't you go there? It's weird.
I don't know.
What? Really?
I'm
Okay,
not
let's just
sure.
end the lesson now. If it's finished that quickly, then Okay, I'll see you then.
See you.
Tomorrow. Okay, so tomorrow is what we'll expect for tomorrow then?
I think a bit of science.
Okay, let's do science tomorrow then.
Okay. Have a good day.
Happy day then. Okay, that's the end of my videos. Please like, share this video with your friends, subscribe to my YouTube channel, and press on the bell button next to the subscribe button so you can get notified about my new uploads, okay? You can also press follow my Facebook, but please don't add me on Facebook as friends, okay? Cảm ơn các bạn đã theo dõi nha. Các bạn hãy nhấn vào like, chia sẻ video này bạn bè các bạn. Nhấn vào nút đăng ký kênh YouTube mình và nút cái chuông kế bên cạnh để đăng ký kênh á, để mà các bạn sẽ được thông báo về những video mới nha. Các bạn cũng có thể nhấn vào nút theo dõi Facebook mình, nhưng nhớ đừng kết bạn Facebook mình nha. Thank you and see you. Bye.